block on an inclined plane moving down the plane only under the influence of gravity. Now, if we draw an inclined plane, this plane right here is inclined at some angle theta. This is a 90-degree angle, straight down, straight across. If it is at some angle theta, then we can draw gravity acting straight down from the block, and we'll label that force due to gravity. The normal supportive force is, if this is the plane, the normal supportive force is directed perpendicular to the plane. So this is Fn. And this force we would call F perpendicular, and this force would be F parallel. That would be 90 degrees. The normal force and the F perpendicular force are in line with each other. F parallel is the force that is parallel to the plane. So the force of gravity that's acting down has component forces of F perpendicular and F parallel. Now we've got a problem. We've got an angle here, and I'm going to go ahead and tell you that is the angle theta, but now let's figure out why. If you had an XY axis, and you were to rotate that XY axis by some angle, that is the inclined plane, that is the perpendicular drawn from the plane. If you were to rotate that, if this is the angle theta, and this axis were rotated up, then that is the angle theta, that is the angle theta, and that is the angle theta. So you took an axis that was 90 degrees, and you rotated it over. So all four of these would be the same values because it's your axis that's moving. And if a line is straight down and opposite the normal, a line is straight down and opposite the normal, that is your angle theta here, and that's a 90-degree angle. So that shows that this right here is that, and this right here is the entire inclined plane. Okay? So that's why this angle is equal to theta. Now let's solve the rest. The sine of theta is equal to opposite over hypotenuse. So sine theta is equal to F parallel over, the hypotenuse is opposite of the 90-degree angle, which is FG. So F parallel is equal to FG sine theta. We showed earlier that FG is equal to mg, so this is mg sine theta. Cosine theta is equal to adjacent over hypotenuse. The adjacent side is F perpendicular, so this is F perpendicular over FG. So F perpendicular is equal to FG cosine theta, which is mass times gravity times the cosine of theta. All right, now, the block on the inclined plane moves down the plane only under the influence of gravity. So it's moving down the inclined plane. There has to be a frictional force here. We're not neglecting friction in this problem. There is no applied force. F parallel is acting downward. Force of friction is acting upward. So we're going to call that the x direction. The sum of the forces in the x direction are going to be equal to F parallel minus force of friction. Those are the only two forces along that axis. That's equal to mass times acceleration. F parallel, we just showed, is equal to mg sine theta. So we substitute that, mg sine theta, minus force of friction we showed earlier. The force of friction is equal to mu Fn, and the force of friction is equal to, in this case, Fn is opposite of F perpendicular, so that's equal to mu F perpendicular. And F perpendicular, we just showed, was mg cosine theta. So that's mu mg cosine theta. So force of friction, we'll substitute mu mg cosine theta. That equals ma. Now, the masses are in every term, so they cancel out. you're left with g sine theta minus mu g cosine theta equaling acceleration. And if you want to clean that up just a little bit, acceleration will be equal to g sine theta minus mu cosine theta, and that would be your acceleration. All right, let's see. That's really all you would have to do because it's not moving up or into the incline, so you don't have to really solve for the y direction. It's only moving along the plane, and that would be the acceleration.